Yep, that's me. Music is too loud. I usually leave it in 18. I think it's good. I guess it's good. Let me just zoom in a little bit more because you can't see me. Oh, there we go. That's it. Cool and nice. So thank you for joining. Starting intro to CSVs and Pandas, of course, with Python. Cool. So thank you, Wei, because basically that's an intro. He made an intro for me. Cool. If you can register here, that'd be great. Piece of comment. There we go. That's it. Yeah, that's the registration link. There we go. Starting with 5 minutes. Already started. Cool. Nice. So hey everyone, welcome to intro to CSVs and Pandas with, of course, Python. My name is Charbel. People call me Bully. You can call me by either nickname or name. A little bit about myself is I'm a robotics engineer. I am a pod leader and a streamer at MLH. So having fun. It's been a while since I streamed. But yeah, always have fun. Cool. Yeah. Recordings available for these. I think on YouTube. I think you can find them on YouTube. I'm not sure about Twitch, but on YouTube, yeah. Yes, Pandas. Cool. Okay. So nice. Let's go into. Oh, that does look good. Should I do? No, that's not good. Yeah, that's good. Okay. Cool. So, yeah. Again, you can find the recordings on YouTube. That's where we usually keep them. But yeah, you just find them there. Okay. Nice. Okay. So is this one? Can I do this? Yeah, I think it looks good. If you need me to zoom in to Colab, just let me know. Okay. We're going to use Google Colab, which is for people who don't know. Okay. Google Colab is basically this Jupyter notebook tool from Google that you can use. You just need a Google account. That's it. Yep, you can write Python here. For example, print hello. Yeah, there we go. And then that's it. Okay. Cool. Hey, Karime. Nice. Okay. So let's dive into Python, CSVs, and Pandas and everything. Cool. So what's a CSV? Like, that's probably the first thing that, if you don't know what a CSV is, it's probably the first thing that you think of. By the way, there's a crab there. If you want to add crabs to your Google Colab, you go into, was it in, I think it's in view? Nah, it's in runtime. Yeah, no. Where was it? Oh, cool. Tools, settings, and then you can go to miscellaneous. There's a kitty, a corgi, and a crab. I love crabs. Why not? But yeah, there's a crab there. Cool. Why? I don't know. Google devs being Google devs, they're really cool. Nice. So what's a CSV? So a CSV means a comma separated value. It's basically a way to store data in an Excel format. Okay, very useful in data science. Very useful when you're training AIs, neural networks, lots of things. Okay, we're going to learn how to basically manage, use CSVs. Let's call it the old-fashioned way, which is with Python and the CSV library and Pandas. Okay, so if you ask me, hey, what do you prefer, Pandas or the usual CSV library? Pandas. Okay, I'll show you why. It's just breeze friendly. But yeah, cool. Let's just dive into this. Okay, so I have a cheat sheet here. Let me just zoom in. Can I zoom in? Yeah, cool. So we're going to use a Kaggle dataset. Okay, a dataset is basically CSV full of data. Okay, that we're going to use and play with. Okay, cool. So in order to run commands in Google Colab without them being Python, start with an exclamation point. Okay, so if we have to do pip install Kaggle. Okay, and in the same slot. Okay, the same cell, you can do make dir, which is that command for creating a folder. Okay, so we have to make a dir called, how can I, oh, shoot, wait a minute. This thingy that I don't know how to use. I'll just have to copy paste it, Control C, there we go. This, is it called tilde? I think it's called tilde. It's a weird name. But yeah, and we have to dot kaggle, okay? And then we have to copy kaggle.json, okay? And I'll show you where to get that kaggle JSON, and do this here, okay? And I'll explain in a second what we're doing in chmod 600. I'll explain in a second, just bear with me. And kaggle.json, okay? And then, yeah, on YouTube, yes. Kaggle datasets. Okay, I'll do this in another cell. Okay, cool. Let's just review what we're doing. Okay, so I'm saying, hey, Mr. Google Colab, please install Kaggle. Okay, I want to make a folder called .kaggle. Okay, I want to copy kaggle.json, which I'll show you what kaggle.json is, into this newly created folder. Okay, chmod is to change the permissions of a file. Okay, so we're giving it 600. I think, I don't remember the numbers. I think it was read and execute, not write. Okay, to the sudo user, and 00 for the other users. Okay, we're just interested in us, which we are sudo, to this file over here. Okay, sounds good. Nice. Before we run this, okay, if you go to Kaggle, okay, how can I share this? I think I have to. Okay, I'll show the entire screen, because why not? Share screen, entire screen. This one over here, okay. Add to stage. There we go. Cool. So this is Kaggle. Okay. Kaggle is a web page where you can find lots of data sets. In this case, for example, there's a traffic signs detection, and you can see here, for example, that we have a video, we have here the data, we have a training set, a validation set, and a testing set. This is for AIs. Okay, this is Kaggle. Okay, you can either click download to download a dataset, or you can import it in Colab, as we will do. Okay, about kaggle.json, if you go to your profile, okay, you go to settings, and then you go to, where was it? Email address, account. Here it is. Okay, API. You click on create new token. Okay, and it'll give you a kaggle.json. Okay, if it's called, I don't know, Kaggle personal or whatever .json, just change the name. Okay, which in this case should be this name here and this name here. Okay, the way to import it is you click on this folder icon, upload to session storage, and I'll upload mine, which is that's the personal one. Here it is. Okay, kaggle.json. There you go. Warning. This basically says, hey, the things that you import here are not going to stay forever. Okay, basically. Cool. Now that we have kaggle.json, we can get rid of this now. The way I run my cells is Control Enter. Okay, so Control Enter, and you'll see it's thinking. It's saying, hey, I already have Kaggle, just in case we download it, and it's doing magic. Okay, cool. Now, if you click on this icon, you won't be able to see this because it starts with a dot. Okay, so don't worry if you don't see it, it's there. Okay, trust me. Cool. Now, here's what we're going to do. We're going to download a dataset. Okay, so Kaggle datasets, download -d for datasets. Okay, and it's Y0 Yusuf with double F. Oh, it's double S. Candil / BMW sales dash 2010. I said 2010 to 2024 dash dash unzip. Okay, what we're doing is we're downloading a dataset from this user over here. This is the name of the dataset. Okay, dash dash unzip means whenever you download something, it'll unzip it automatically. Okay, so let's run that. I hope I don't have an error. Ah, great. Yusuf Candle BMW sales. Oh, it's not with this dash. My bad. Yeah, there you go. Cool. So you should get this. Okay, this means it's downloaded the whole thing. Yep, 100%. Okay, you can go to your icon. You can see BMW sales data 2010 to 2024. Okay, let's double click here and see what we're working with. So this is a CSV. It's a spreadsheet. Okay, it's an Excel. Okay, you can see there's a model, year, region, color, fuel type, transmission, engine size, mileage, and more information about cars, specifically BMWs. Each column presents one of the titles, so model for this whole column, year, you have the year column, and every row is a car. Okay, so in this case, the first row is a 5 Series, 2016, the region is Asia, and the price, which is what do you want to see? $98,000. But that's, I don't know. If BMW wants to sponsor me, please do. You are late. No, you're not late. This is what we have done. Okay. If you don't know Kaggle, just import your Kaggle JSON API key. I'll just copy paste this code. Okay. And download this dataset right here. Okay. You are not late. Cool. Okay. So that's the dataset. Okay. Now we want Python to read the dataset, not us. Okay. Or us with Python. Okay, so let's do that. If you kind of hover over the cell under it, it says plus code. Okay, so click here to add a new cell. Okay, here we're going to do something interesting. Okay, so import CSV. Okay, this is the library that Python uses usually to read CSVs. Okay, it meets the requirements. It's not something that you would use in your day-to-day, work. I don't. Okay, I use Pandas all the time. If someone does, yeah, kudos, because I don't know, it's a little bit funky. Okay, we'll open our file. Okay, with open, and now what I recommend is go into your file here, click on the 3 dots, copy path, and paste it in your string. Okay. And then after this, new line equals nothing. Okay, so there is new line, okay, because sometimes the CSVs have a line without data, so we have to skip it. In this case, we don't, okay? As F, okay, this means we're opening the CSV as a file. The file is called F, okay? So the way CSV does it, okay, is we have to get an object that's called a reader. Okay, so get reader object. If you're following the code, you can omit these, which are comments. Okay, they're not relevant for the code. Okay, it's just for you to understand what I'm doing. Cool, nice. Reader equals CSV dot reader. Okay, and what are we reading? F, which is this file over here. Okay, nice. So let's see it. Okay, let's see what this is. You'll say, hey, I'll probably just see a lot of data. Okay, not quite. See, when I run it, it says CSV reader object at blah. Okay, just FYI, what this means is if you see a 0x, it's a hexadecimal, let's call it direction in memory. Okay, so it's saying there's an object here, basically. Okay, but we're not reading the object. It just says object. Okay, how can we read it? So let's just get rid of print reader. And let me get the first row of the reader, okay? First row of the reader object. Cool. And we can do header equals next, okay? Reader, and I'll explain in a second what this does, okay? Let's do that. Print header. Ooh. Okay. What is this? Like, what's happening? Okay. Next is an iteration to the next part of the object. Okay. So we're saying, hey, don't give me the object, as if you would do a for loop just once. That's what next does. Okay. So give me the next item in reader, and you can see it's model, year, region, color. Remember where this is from? Model, year, region, color. See, it's the header, okay? So we're reading the first line, which is the header, okay? What about if we want to read more lines? Well, that's easy, right? We can do, if this is one step for loop, let's just do multiple step for loops, okay? For row in header, no, in reader, my bad. Okay, for row in reader, print row, okay? This'll make Colab a little bit crazy because it's a lot of rows. There you go. Cool. So if you scroll all the way up, so I recommend finding the little thingy here. Oh, there we go. Cool. So scroll all the way up. More. There we go. Cool. So, okay. So you can see it's more than 5,000 lines, so it got rid of the header. But you can see there's a Model X6, a 2010 car. Price is 69,000. Okay, again, if BMW wants to sponsor, I'm open, okay? I don't know if MLH is, but I am. Cool, so reading the CSV, okay? And you can see every row is a list. Okay, so you can access iterating through the list each and every single data, okay, which is in this case a string. Cool. Okay, let's go to the next cell. Okay, don't scroll in here because you will never finish. Okay, scroll outside. Okay, code, and let's write something more interesting. Let's store it in a way that we can easily access to it. Okay, because lists are, not accessible. They don't have key value pairs. So if you want to look for something specific, it'll be hard. Okay, so let's do it with this, with open. The whole thing again. So let's copy paste the whole thing. It's with this. You don't have to import CSV again. Okay, if you import it in one cell, then it's fine. It works fine. Okay, cool. So with open, the same one. We get the reader object, okay, equals CSV dot, in this case it's dict reader, okay, it's a reader in a dictionary form of F, okay, and let's do the same thing for row in reader, print, let's do print row, let's see how this looks. It'll go crazy a little bit. Give it some time. Ooh, there we go. Cool. So you can see now, okay, for those who are not Python programmers or are just learning Python, you can see that you have some curly braces here. This is a dictionary or a hash map. Okay, here you have a model. So this is a key and this is the value. Okay, so for each row, you have key value pairs. A model X5, year 2010, region Middle East, color black, blah, blah, blah. Okay, and you can access them by keying. Okay, let's see how that looks. So print row, but I just want the models. Okay, I don't care about anything else. Let me just get the models. Okay, row, braces, string, model. Okay, careful, because the column name, if you can see it here, it's with capital letter. Okay, if we don't do capital letter, Python says, I don't know what you're talking about. Okay, cool. So capital letter, model. Okay, run this. Ooh, now we filter some data. Okay, so we don't have the junk that we had before. Now we have only models. And you can do the same thing for price, for all of the data, or for all of the columns that we have. You can do the same thing. Okay, cool. So far, so good. Okay, if you have any questions, just let me know. Okay, let me know in the comments. But yeah, that's how we get the models. Okay, you can start to see it's, I don't know, it takes time. When you're writing Python, I want to write something that's pretty fast and simple, not a C++ thingy, okay? I don't like this, okay? There's a better way to do it, okay? But let's just explore it a little bit more, okay? So, again, scroll outside of the box, not inside, because if not, you'll scroll the whole output, okay? Let's just count. Let's see how counting works in this part, okay? So we can do total and count, both of them equal 0, okay? I hate doing it this way. I don't know why I did it in my cheat sheet, but yeah. Whoever does that, I don't know. Seek help. Okay, cool. So we do with open. Again, the same thing. Slash, I'll write it down manually. I don't like copy pasting code. I think if you write code manually, it sticks. Okay. Cool. So slash content slash BMW sales data parentheses 2010 dash 2024 dot CSV. Okay. Again, new line. There is no new line. Okay. As F. Cool. So far so good. Same thing. Let's get the reader object again. So reader equals, let's get a dictionary, okay? CSV dot dict reader, fine, parentheses F as usual. And now let's kind of get the average price of all the cars. Okay, so average means I will sum up every price of every car and then divide it by the number of cars. Okay, so let's do get the average username. Don't know if it's, oh, okay, careful here. If I think that error is because you don't add this username. It should be, okay, I'll send it here. That's the username, okay? So the whole command should be like this. Try that. If it's the same, then make sure that your kaggle.json is tied to your Kaggle account. Okay, just let me know. Okay, cool. So let's just get back to this part over here. Yeah, let me know, Philson. Okay, cool. So get the average. So let's do total plus equals means I will sum and keep. Okay, int. Okay, I'll explain why int in a second. You get the row of. Oh, by the way, we have to for loop this. For row in reader. Okay, careful with the indentation. So you should tab this. Tab here. Okay, int row in price USD. Okay, like this. And now count plus equals 1. Okay, so we have to count every single one of the rows. So we do the average. Okay, in the end, we can do print. Let's do an F string here. Average sales is open curly braces, and then put total over count. Okay, that's it. Okay, the F here stands for an F string. If you remove it, you cannot use variables inside the strings. So add the F here. Okay, let's see how this looks. Ooh. Okay, so your average car, average BMW from 2010 to 2024 is roughly about $75,000. in Mexican pesos, because I'm from Mexico, I think it's 75,000. I think it's like 1.5 million pesos. Yeah. Again, please sponsor me, BMW. Cool. Okay, so we got the average sales. Okay, and sales with one S, my bad. Okay, cool. Let's just do something more interesting, okay? Let's do some statistics with this, because when you are doing data or working with data, you have to do some statistics, okay? And you'll ask yourself like, hey, why are we doing this? Like, what's the why? I kind of want to make sure that you get why to use Pandas, okay? I want you to love it, because if not, if you use CSV, like kudos if you use CSV, but get help, okay? Because it's just a lot. You can see we'll do this in 2 lines of code, okay? We'll get to that. Cool. Okay. By the way, Philson, did my code work? The one that I sent or not? Just so me know. Cool. Okay. So from collections, my bad. From collections, import. Counter. Careful with the capital C. Okay. Cool. So let's do this again. Same thing. I'll copy paste because why not? Okay. It's just the same line of code. I know what I said. Let's just copy paste it this time. Okay. Same thing. Dict reader. Okay. And let's just get the rows as lists. Okay. So equals list reader. Okay. So I want a list and I want a dictionary, okay? The easy way to do it is like this. Cool, okay, so we can do prices equals, it worked. Yeah, that's fine, cool, awesome. Yeah, what I do, this whole cell, I have it in like in Notepad because I use it all the time and I usually forget 1 line or 2. So yeah, it's good to have it laying around, okay? Cool, but nice that it worked. So prices equals, we'll get a list int, because every single one of these are strings, even numbers. See, you have the thingies there. Same thing here. Okay, so we have to convert it into numbers. Okay, we do int, and then r. Okay, we'll get to that in a second. Get for price with capital P. I said capital P. Price USD. For, oh my bad, it's outside of this. For r in rows, if r price USD. Okay, what happened? What just happened? We are getting the prices, converting them to integers of every price USD column for every row called price USD. Okay, so far so good. It's a for loop inside of a list. Okay, we're basically getting all the prices. Okay, and converting them to ints. Okay, cool. Now, let's do the same thing for models. Okay, models equals list of, we don't have to do int because it's a string. We care about strings in this case. Our model, again, model capital M, for R in rows if R in model. Okay. Same thing. We're getting the models and storing them in the list. Okay, cool. Now, let's print all car prices. Open square thingies, and then do prices. Okay. Print same thing. F min price. It's, let's just use the minimum function in Python and then do prices. Let's do the max price too. print f max price, open these brackets, and max of prices. Okay, same thing. And then let's just get the most common colors. Okay, that's why we imported counter. Okay, so let's do print again f string, and then we go to most common colors. Open this, and then do counter dot, oh, actually counter, and I'll explain what counter does in models dot most common, and we want top 3. Okay, let's just get the top 3. Okay, cool. So what does this line do? Counter works with dictionaries. Okay, so what we're doing is, hey, from this list of car models, I want you to give me a dictionary counting the models and give me the most common models top 3. Let's take a look. Cool. Okay, cool. Now, minimum price of a BMW between 2010 and 2024, 30,000. Yeah. Maximum, 120,000. Like just plus tax here. Okay, so 120-ish. Yeah. Wow. Cool. Okay, you can see that you have a lot of prices. Okay, we worked with all of these prices to get these two. Okay, you can see most common cars are the 7 series with 464,666 models, i3 for 4,600-ish, and i8 for 4,600 too. Okay, so rough estimate. Okay, we had to do all this to get this. Not bad. There's a better way to do it. Okay, there's just a lot of ways to do it, but let's just do it the better way. Okay, cool. Before we go into the better way, let's see how plotting looks. Okay, so you have to look at your data always. If you're working with CSVs, with images, with, I don't know, whatever you're working with, I want you to see it. If you don't see it, you don't know what you're working with. Okay, bullet. I can see it there. Like, what's the difference? Yeah, plot it. Okay, I want you to plot, I don't know, color versus fuel type. Let's take a look at how to plot and how to not plot. Okay, cool. So import matplotlib.pyplot pyplot as plt. Okay, matplotlib. Yeah, there you go. Okay. So I'm sorry, my typing today is just not there. Okay, I don't know why. Cool. Let's see, what can we plot? Okay, so we can plot x over y. Okay, so we can plot, I don't know, let's do engine over transmission, mileage over color. We can do whatever we want. Or can we? Let's just take a look at that. Okay, so let's see, what about, I want to get the colors. Okay, so colors equals the same thing, are in color, capital C, okay, for are in rows. Okay, we store rows here. I'll just get rid of this because it doesn't help. If are in color, okay, we have color. If not, then just skip. Okay, cool. Now plt, which is matplotlib dot bar, which is a form of bar plotting. Okay, well, let's do colors versus models. I think people are some of you are starting to see, hey, something doesn't work. Let's go with that. Drink some water. Why not have an energy drink? I drank one today earlier. I don't know if 2 do something to your, or does something to your heart. I don't know. I don't want to find out. Cool. plt.x label. This means I want to label every x with colors. Okay, first one is colors, and then the same one is the Y label for models. Okay, and do plt.show. Okay, 3, 2, 1, ready? Now, what's happening? So it's not that collab is stupid. It's not that collab is slow. It's that we are not plotting correctly. So if you want to pause this, just click one time, okay? Just one time into the square, let it think for a bit more. It says, hey, error, you interrupted, okay? It was your interruption, okay? It's thinking, and whatever it wanted to plot, it'll show it to us, okay? Interesting. We have a malformed plot. It means we wanted to plot in a bar. Was it color? Red, blue, black, silver, white against models, okay? And you can see it here actually. There's a 5 series that's blue and a 5 series that's red. In a 2D plot, you cannot plot this. Because Kaggle or Collab says, hey, I don't know, I have a 5 series that's red, I have a 5 series that's blue, but I have also an X3 that's blue. So it's too complicated, or it has a higher complexity in terms of dimension. So a 2D plot won't work. Okay, because you have repeating values in different values. Okay, so no can do. Okay, this is the bad way to do it. What's the good way? Well, that's good. Stick with, or I'll see you on Monday for my data science and linear regression stream. Okay, a little bit of marketing here. Cool. Okay, that's the bad way to do it. Okay, let's do it in a different way. So that's why it doesn't work. Okay, cool. So let's do it in a different way. We can count the colors and say, hey, I want to know how many blues, how many reds, silvers, whites I have. So let's take a look at that. Okay, so colors, so color count equals, again, counter. Okay, no need to import counter. You import it here. Okay, so no worries. Here, I want to get R, or actually, can we recycle code? Let's see if this was stored. Okay, colors. Okay, we can do it like this. So, plt.bar, okay, same thing. Let's do color counts dot keys, okay, which means from all of the colors that you counted in the dictionary, give me all the keys. Okay, so it should be the red 25, blue 46, so on. Okay, and I want you to give me as a Y color counts dot values. That's it. Okay, plt dot x label, which means I want to label the x. You can skip this. It's not visually appealing. Okay, if you're working with data, please make it as visually appealing as you can for you. Because if you go back to your code, you won't understand it. Okay, if you're presenting your data science project, people won't understand it. Okay, beautiful data is easy to work with. Okay, cool. So color in x plt.y label, and we can do number of cars. And there we go. And now plt.show. Ready? 3, 2, 1. Will it work? Ooh, it worked. Okay, let's see here. Okay, we have color. See, this is the X label. This is the Y label. Okay, without these, let me just get rid of them for you to see. You can, I don't know, it doesn't look good. You can actually add a title here. I think it's plt.title. Let's do plt.title. We can do color counts. Oh, see that. beautiful. Okay, that looks good. Okay, that's a good way to plot. Okay, please do it that way. Cool. So you can see red, blue, black, silver, white, and gray are the only colors that we have in this dataset. Okay, my personal take. Okay, BMW, if you're listening to this, please give me a black i3. X. That would be good. Okay, a number of cars is, for example, we have the most cars that have been sold are red. Okay, now you can say, hey, I could have just summed, or I could have just done print color counts in, is it yeah, red, like this. So see, it's the same, right? Like I just, here it says 8,463 red cars. I prefer this way. Okay, because it's visually, you can visually see, it's not important for us at this moment to know the exact number. We know that we have like the most sold cars are red, and then silver, and then I think it's white, gray, blue, and black. Okay, yeah, plot your data. Okay, best thing to do in the world. Cool. Okay, nice. Chapter 1 complete. This is the old-fashioned way to do things. Okay, it takes time. You need to learn a lot of Python syntax, which is not bad. Please do it. That line of code does a big difference. Okay, import pandas as PD. Okay, this means I want to import pandas and use it as PD, not pandas dot something. Okay, if you don't do this, if you do it this way, it's not an error, but you have to do pandas dot blah. Okay, I want to do PD dot blah. Why? Because it's easier. Okay, it's just easier to write. Okay, so import pandas as PD. Okay, that's the usual way to do it. Okay, cool. Now we have two things in pandas that I want you to know: series and data frames. Okay, series are a one-dimensional data way to store data. Okay, or yeah, that. Okay, so it's one-dimensional. Data frames are two-dimensional, which means rows, columns, rows, columns. Okay, so that's the way we do it. Let's see how a series looks like. Okay, as for a series, you can name your variables as you want. Okay, PD.series. Careful with the capital S. Okay, series, and then let's just make a list of 10, 20, and 30. So far so good. Okay, it's just a number. It's a list of numbers. Okay, nothing weird. And then I want to name these, okay? So it's not that I'm going to give them a title. It's just I want to name the rows. So you do index equals, actually it's a list because we have 3, okay? So index equals A, B, and T. Okay, now let's see how this looks. Okay, cool thing about Google Colab is if you just write the name of the variable, it prints it by itself. So from now on, if you see just a variable name like this, it's because I'm expecting a print. Okay, cool. This is a series. Okay, you can see it's one-dimensional. It doesn't have more complexity. It's just a list of numbers and the indices. Okay, that's it. Nothing more. Okay. Now, we can do something interesting, and you can say, hey, how can I know if S, or what S is, basically? If you do S, I said s.info, and run it, you can see, ooh, this is a pandas core series object, okay? It has 3 indices, A to C. Series name, it doesn't have a name for now. Let's leave it that way. It's a no-name series. Meh. We have as the data types, which are in this case integers, there are no null, count D type. Okay, so 3 non-null, 10, 20, 30, and all of them are integer 64. Okay, memory usage 156 plus something bytes. Nothing. Okay. See, now this is helpful. Okay, we'll get to that in a second of how this is so helpful. Okay, so what about our BMW dataset? What can we do with it? Glad you asked. DF. A DF is the usual way to name the data frames. Do I name them that way? I don't. Just for the sake of the stream, I'll do it. But I usually do something like BMW dataset. Okay. Just in this case, because I'm writing a lot of code, and I'm talking at the same time, and I won't get back to this code for something more professional, which means it's not an AI project that, I don't know, Llama from Meta depends on it, then I don't care about the names. But yeah, rename your variables in an easier way to understand them, okay? In this case, df for data frame equals pd dot read CSV, and let's do content. I think it has to be /content, or let's do it the easiest way to do it, okay, which is click here, BMW sales, copy path, paste it here, and let's do df.head. Okay, let's see how this looks. Ooh, cool. So let's take a look at the difference, okay? This is a data frame. One line of code, we got the whole thing. Okay, now you say, hey, we have from 0 to 4, which are the first 5 lines. How can I take a look at the whole thing? Oh, okay, let's just print it. Here's the whole thing, okay? It cuts some of the rows for you to see it completely, okay? Here it is. The format is better. The way to import it from CSV is better, easier, compared to, well, this, which is not bad. Again, it's just very C++ for me. Like, I would rather do it in C++. It's just way faster. Okay, if I'm using Python, I want it to be easy. Okay, that's the magic of Python. Okay, Python is really slow, really good with data, because it's just, you don't have to worry about the syntax that much. If you go into objects, probably, but in this case we don't. Okay, cool. So what does df.head do? Df.head is, hey, I want to get the first 5 rows of the data frame and plot them. That's what df.head does. Okay, cool. We can see we have the model, the year, the region, even the price, which is $98,000. Again, BMW, please sponsor me. Cool. Okay, so let's take a look at the information. Okay, so df.info should give me something interesting, right? You can see it's a Pandas data frame object. It's a 50,000 row, numbered from 0 to 49,999. We have 11 columns, which are model, year, region, color, fuel, transmission, engine, mileage, price USD, sales, and sales. Okay. D types, we have one float 64, which is a floating number. This is a floating number, okay, with a decimal point. We have integers, which are non-decimals, and objects, which are strings in this case. Okay, that's the information. We're using 4.2 plus megabytes. We have a lot of data. It's not that much, okay? Considering that you can use data frames of gigabytes, yeah. Now, careful with that. If you want to load data frames that are like 4 or 5 gigabytes of like, that's their weight, this is loaded in RAM, okay? So if you're working on your computer and you want to load something that big, make sure that you are, like, you have 32 gigabytes of RAM. If you don't, then you can't do it. It'll crash. Okay, it'll tell you, hey, I don't have enough memory. I'm sorry. Okay, cool. Careful there. Nice. Okay, cool. And you'll ask, like, hey, you can ask yourself, like, hey, where would I get a 2 or 3 gigabyte plus data set? Images. Okay, if you're doing image recognition, careful. Okay, it's very easy to have or to run out of memory. Okay, just be careful with that. Cool. Okay, let me just open here because it's a little bit warm. There you go. Nice. So, cool. Now, how can we index? Okay, so we have a data frame. This whole thing. I just want to get the models. Okay, same thing as we did before. Give me the models of, you know, the data frame. Okay, we can do easily df models. Oh, is it model? There you go. See, now, if we do this, this is maybe a series. See that? Now, we transformed a data frame into a series by just getting one column. Okay, this is a one-dimensional data frame, which is called a series. Okay, and you can see model 5 series I8, 5 series X3, so on, using it or indexing it as dictionary. Okay, as simple as that. Okay, it's really cool. Nice. Okay, so after looking at that, can we say, hey, can I get 2 different columns? So if I can get 1, I should be able to get 2, right? Let's take a look at that. Okay, df in model and price USD. Doesn't work that way. Okay, let's see. Usually when people get errors, if you're that type of person, don't do it. Okay, don't skip the error. Let's just read through it. It says model price USD. Okay, that's the key error. It says it's a direct cause of the following exception. Okay, it is type error. Okay, so it's an error of a type, meaning it's expecting something that we're not giving it to it. Okay, it says if we have list like key, check indexing error will rise. Okay, but in this case it's not that error. But if we read, it says if we have a list like key, it's probably expecting a list of strings. So let's try that out. Okay, we can do this. My iPad is running out of battery. Give me a second. Cool. There it is. And close it. And let's see how that looks. Ooh. Okay. Don't freak out when you get errors. Read them. It says what the error is. You just have to, get used to them. Okay. We have now model and price USD. Now, what is this? Is this a series? Is this a data frame? What would you say? The only way to do it and to know it is .info. Now, this is a data frame, see? If we have 2 columns plus, we have a data frame. If you have 1 column, it's a series. Okay, series and data frame act the same, but they're not the same. Okay, cool. So, again, we can see this. We get price USD and model. Okay, so when you get a data set, usually, not all the time, you get rows or columns that you don't want. Okay, just get rid of them and that's it. Okay, for example, if we take a look at BMW sales 2010, can I find it? Datasets. Here it is. Okay, this is the dataset that I use. You can see here the model, the year, the region. So for example, I want to work with everything but mileage. Okay, I don't care about mileage. Okay, just as an example. So what I would do is I would list all of the column titles except the mileage. And you can even do this. New df. Oh shoot, my bad. Give me a second. Was it like this? Yeah, I think that's better. New df equals df in these 2, okay? And then let's print new df that head. Ooh, .info. Oh, my bad. Head .info. Cool. So now we have a new data frame storing the other data frames column, and we have it here, 5 entries, 0 to 4. Okay, because we are heading. Okay, if we don't do the head, we get a 5,000 entries. Okay, so we just filtered it. Okay, I recommend you filtering your data sets like this, because if you filter them, if you do this, I won't run it, because if not, we'll lose some data. If you do this, you're rewriting your data frame. And if you say, hey, I probably needed some other columns, then you have to re-download the whole thing. Okay, which is not the best thing to do. Okay, so store it in a new data frame. Okay, cool. Now, nice. So, yep, that's the data frame. Okay, cool. So it's easy to list and index columns. What about rows? Okay, so hey, I want to get row 5, 6, and 7, or I want to get row 85, 95, 2000. I don't know. We have two interesting functions. Okay, iLock and lock. Okay, so iLock stands for integer location based indexing. Okay, let's use lock in a different cell. Okay, what this means is, hey, I can get, based on an integer indexing, rows. Okay, let's do it. Data frame that I lock. Okay, and it's a list 0, 1. This means I want to get row 0, column 1, which this should be the year column. Okay, okay, let's get that. Let's see it before we run it. Let's do df here. Okay, we can take a look at row number 0, which is this one over here, column 1, which is year. So row number 0, column 1 should be 2016 or 2016. Okay. Ooh, check this out. Okay, interesting. 2016. Now we can do df that iLock 0. Ooh, interesting. So the first one, this one, df iLock 0, 1 is, where is it? Let's do x, let's do y. Cool. And then let's print x, and let's print y. See, so x is 2016, okay, and the other one is the whole row. It says model 5 series. Let's confirm. 5 of 2016 Asia, 5 2016 Asia. Red petrol manual, red petrol manual. See that? So we are getting, let's just get, I don't know, row 5,000 or row 49,999. We got it. Here it is. You can see it here. It's an X1 2020 North America blue diesel manual. Price of 77,000. Price USD 77,000. Same car. That's how you get your rows. Okay, but that's how you get your rows in an integer-based index. Okay, you can get it in a different way. A little bit of water. And by the way, yeah, if you're curious, oh, you can't see it. Well, that's bad. It's one of the dwarfs from Snow White. It's bashful. Yeah, my grandma just gave me that mug. It's really good. Cool. Okay, just a little FYI there. Let's do lock. Okay, so lock stands for a label based. What's wrong with me? Based index. Okay, it means you can use strings to filter your rows. Okay, let's see it. What if we do df.lock? I want to get row number 2, careful, not the second one. It's row number 2, which is the third one, okay? We're starting from 0, so it's 0, 1, 2. So it's the third row, number 2, okay? And then we can get model. Let's see how this looks. This means row with index 2, column model, okay? Ooh, it's a 5 series. Should we check? We always have to check. Row number 2, not the second one. Again, we're starting from 0, 1, 2. It's a 5 series, okay? Well, let's check if it's really that one. Let's just get the price USD, okay? So model price USD. Okay, we can actually do the same. We can do model like this. Ooh, can't we? Can it be a string, a list? Should it be a list? Maybe. No, it's not here. It's here. I guess. Nope, it's not that. Not an index. Price USD. Model price USD. Can I just get one? Or can I do probably this? Oh, there you go. Cool. So we can get the second row. I want to get the model and the price USD. It's a 5 series at 113,000. 5 series at 113. There we have it. Okay. We are filtering rows, indexing them, okay, and indexing with with strings the columns, okay. Now you can, instead of doing 2, you can do a string too, but in this case we're indexing them with numbers, okay. So each row has a number. In this case, if you remember the series, it has strings or characters in this case, okay. So it depends on your data set and how you're working with it, okay. But in this case, it's numbers, okay. But you can still change this into a string if it fits your case, okay. Cool. I just got tired of the crap. Let's do kitty. There we go. Nice. Okay, let's just get kitties there. Cool. Okay. Another thing that we can do is, can we filter data? Okay, so let's see how easy it is to filter data using Pandas. Okay, so we can do data frame, and I want to get every model that's newer from the year 2022 onwards. Okay, so 2023, 2024 should be good. Okay, so we can do df inside of df, and then we could do model greater than, I said greater than 2022, and we can get the cars from range 2022 and 2023 by price sorted. Okay, let's just take a look at this first. Okay, how does this look? Doesn't look good. Oh, yeah. Okay, yeah, careful. I got the model. Model cannot be an integer. Okay, so it's saying, let's just read the error. It says bigger than is not supported for string. Okay, so careful there. Okay, don't run away from errors and go to ChatGPT. Read the errors. It says I cannot say model is greater than 2022. It's not possible. Okay, my bad. It's year. Okay, go. Cool. There we go. So we get a data frame. Okay, a filtered data frame, and you'll see that every year from here, it's greater than 2022. And we have 6,000 rows. Okay, so we left out 43,000-ish rows. Okay, so 43,000 cars are between 2010 and 2022. And the rest, which we have here, are in 2022 or greater than 2022, okay? Oh, my bad. There's not enough light. Let's see. Does this work? Is this better? Yeah, cool. Nice. Okay. Let me just change the light. There we go. That should be better. Cool. Okay. So that's a way we can do it, okay? Let's just keep this cell like this. Let's just go to a new cell. Now, let's do something more complicated, okay? Let's just get the cars from Rage 2022 to 2023 and sort them by price. And you can go and say, hey, that's too complicated. How can I do it? I don't want to do it. Well, let's do it. It's just way easier with Pandas, okay? So let's get the cars, which is df, a list of df. First, get the range from 2022 to 2023, okay? Year bigger than 2022. Let's get it bigger than or equal than 2022. My bad. It's like this. Okay. Close parentheses here. Open parentheses here. Okay. 1 and %. Okay, and I'll explain what this and is. This just works with Pandas. Okay, it doesn't work with Python alone. It's a Pandas thing. Okay. Df year. Okay. Less than or equal to 2023. Closing parentheses. Okay. What does this and mean? Okay, it's basically an and, but it's not a logical and. Okay, it's not comparing. It's just saying this and that. Okay, not this logical and this. Okay, so quickly let's do logical and. Okay, so logical ands are, this is a truth table. Okay, you can see 0 and 0 is 0. Okay, the only way an and can output a 1 if both of them are true. That's a logical comparison. We're not comparing. We're just saying, hey, I want you to give me this and that. Okay, make sense? I hope it makes sense. Okay, cool. So cars dot sort values. We want to sort by price. Okay, so we do by equals price USD. This means I want to sort by these price over here. Ascending equals true. Oh, we can do false. Okay, we can do whatever. You can see we're getting the cars from 2022 and 2023 sorted by price from most, like the most expensive car all the way down to the least expensive car. Most expensive, it's at 120,000. The least expensive is at 30,000. Okay, from year 2022 is an X5. Probably the mileage is the one that's making it so, yeah, there we go. The mileage is at 100,000. Okay, so that's why. Okay, cool. It's raining a lot. What the heck? Okay, cool. Okay, so far so good. Beautiful Pandas. Pandas does a lot of things. Easy. Okay, cool. So let's see. If you hear the rain, just let me know, and I'll activate the AI so it reduces the noise. But yeah, just let me know if you hear the rain. Okay, cool. So let's do something else. Now, I said there's a bad way to plot and a good way. And you might say, hey, it's just plotting. I just want to look at the data, okay? It should be easy. Let's do it the wrong way, okay? Let's do it the wrong way and see how we shouldn't do it, okay? Cool. So, wow, it's raining a lot, okay? Do I have music on still? Yeah, okay, my bad. Because I'm not hearing anything, okay? I'll just do 15, and that's it, okay? Cool. Again, just let me know if you hear the rain, okay? Because it's ridiculous. And I have a roof, like a glass roof, so that's why, okay? Give me a second, I'll just close my door. Yep, that's better. Cool. Okay. So what can we do? So let's see. Let's plot the whole thing. Let's see what Pandas does. Okay. So we can do df.plot. Okay. Kind equals line. Okay. Let's see what that does. It's thinking. It takes time because it doesn't make sense. What's going on? Okay. What it did is just count. It said, hey, I don't know, from things that are actually numbers, which are the year, engine size, mileage, price, sales, I'll just try to do some lines and see what we can do. But that's what Pandas does. It's not a good thing. That doesn't mean anything. Okay, that doesn't mean anything. Let's just do something better. Okay, we can do, hey, Mr. Data Frame, I want you to be grouped by, okay, the model. Okay, I want to group all the models. Okay, from there, I want to get the sales volume. Okay, I want to get the mean of this. Okay, so let's just go back and see it again. I want to get all the models. And from all the models, I want all sales volumes. I want to get the mean. And I want to plot the mean. Okay. Kind equals bar. Okay. Y label equals average sales. You with me? So far, so good? Oh, thank you. What? Sales volume. Oh, sorry, my bad. Capital V. Cool. Okay, so now we can see something better. It's not this weird thing, because that doesn't make any sense. Pandas is just trying to make sense of your data, saying, hey, I don't know, I found something close to 200,000, which is probably a price of something, and the price USD falls down here. It's just weird. It's a mess. Okay. This is not a mess. Okay, let's just get back to it and see. Group by every model, every sales volume. I want to get the mean of every volume of the sales. I want to plot it. Okay, you can see the average sales of the 3 series is 5,000. Okay, the one that's higher is the X1 and it's plus 5,000. It's probably 5,100, maybe 5,200. But yeah. That's how you plot. Okay, this one line of code, it's way easier than doing this whole thing plus this. See that? That's what I love Pandas. Pandas is just way too easy to use. Okay, cool. So let's get down. Let's see. Okay, cool. Now, I have 40-ish minutes. Okay, cool. So let's use another data set, okay? Something more interesting. Because, you know, a lot of BMW. I prefer Audis, to be honest. But yeah, okay. Interesting. A question. Are Pandas built-in methods more computationally efficient than applying custom functions with .apply on a dataset? Good question. Yes, they are. Okay. Pandas relies on, and you can see it here, relies a lot on N64. I saw it here. Wait a minute. Just for you to see it. N64. Oh shoot, I lost it. Okay, Pandas relies on NumPy. Okay, NumPy is a library, a Python library to do very complex math. Okay, NumPy is written in C++. it's a Panda. It's a Python library written in C++. It means it's really fast. Okay, most of the mathematical computation that Pandas does, not fetching basically, is based on NumPy. So it's pretty fast. Okay. I would say it also depends on what you're doing. If you're fetching a lot, which is not NumPy based, then I would say it's the same as if you would do a dot apply. But usual things like this, for example, or like sort values, okay, this is based on NumPy, and NumPy is pretty fast. So Python wise, it's fast, okay. But yeah, if you wanna, for example, if you wanna use it in your interviews, definitely use it. It doesn't make much difference if you use Pandas or your CSV or usual Python. Okay, I think Pandas is even better, faster. Okay, but yeah, again, it's based on NumPy basically, so it's faster. Okay, cool, nice, great question. Cool. So, I have a question, and what do you think? Just if you have an answer to this question, just post it on the chat. Are bigger budgets in movies double equal better movies, better actually ratings? Okay, yep. Is that something that you agree or disagree? Just let me know in the chat. But yeah, are bigger budgets in movies meaning we have a better rating of movies? I have my answer. My answer is no. I would say the budget doesn't, imply a better movie. I think A Silent Place, I think that's how it's called. The one with aliens that we have barely no dialogue. The budget was pretty low, and it's one of the greatest movies that I've ever watched. Okay, it's really good. Okay, cool. Okay, so let's download a new dataset. Okay, datasets. Actually, it's Kaggle. Datasets download -d. It's as far as ash, actually, ash pulse ing 1525 -imdb movies dataset -unzip 321. Let's see what this does. Error. Yes, I love errors. Okay. Ash palsy in GH, yeah, 1525 IMDb movies that's it. Careful with the A. Again, my typing today is not there. I don't know. My fingers. Anyway, cool. Okay, so before we open this dataset, okay, the movies. So this is the least accurate dataset I've ever seen in my life. Okay, the movie titles are weird. Okay, I left it here because it's just really funny and doesn't make sense. Okay, and I want to like one lesson from this stream is careful with your data. If it's labeled IMDb movies dataset, it doesn't mean that it's accurate. Okay, and I'll show you why. Okay, viewer discretion is advised. Cool. Nice. So movie dataset equals pd.read CSV that we know, and let's just get IMDb movies copy path. Remember, paste the path here, and then say, oh, live debugging is always fun to see. I think you would disagree. A larger budget wouldn't guarantee a good script. Director, yeah, good. I guess the budget allows you to have better cast, better effects, those things. But I don't think the quality of the movie changes based on the whole script with a better or worse budget. Yeah, you're absolutely right. Cool. And live debugging, live debugging is fun as long as you can debug. When you don't know what to do, it's horrible. I've been there. Okay, yeah. If you're there, good luck. Cool. Okay, so we get the CSV. Okay, let's get the info. Okay, movie dataset dot info, and let's take a look at this. Okay, we have names, we have the date, score, genre, overview, crew, the original title, status, original language, budget, revenue, and country. Okay, again, this is one of the worst datasets I've ever seen in my life. It's so bad, it's funny. Okay, let's see it. Movie dataset dot head. Ready? Yeah. Okay. So why is it funny? Oh, it's not here. Okay. Cool. You'll get to see it. Okay. But in this case, for example, we have Creed 3, which based on this dataset, it had a budget of $75 million. Really? Creed 3 budget. Okay. Oh, it had. Okay, that's accurate. Okay, cool. That is accurate. We can check, for example, the revenue was really high, 2.7 to the power of 8, which is 270 million ish. Avatar, The Weight of the Water, not bad. Visual effects were really good, but I still prefer Avatar 1. Okay, the first one. But yeah, let's take a look at it. The score was 78, and the budget was $460 million. Let's see if that's true. It's Disney, so I guess it's true. Avatar, The Way of the Water budget. Yeah, 460 million. Okay, so far it's accurate. Okay, now you'll see why it's not accurate in the future. Okay, just bear with me. Cool. Okay, so now that we have taken a look at our data set, we just need 3 columns. We need the names, score, and the budget. Okay, I don't care about the overview, nor the genre in this case. I want to see if bigger budgets means better ratings. Okay, cool. So I'll get rid of those. Filtered. Again, don't rewrite your dataset because you probably may use your data in the future and you have to re-download the dataset. It's not the best thing to do, so just use a different dataset object in a filtered way. Okay, so in this case, filtered equals movies dataset. Is it movies or movie? It's movie. Okay. And I want to get only the names, score, and budget X. Okay. Let's take a look at filtered.head. Okay, this should be the same data set, but just these 2 columns. Okay, we have Creed, score of 73, $75 million. Same thing here, but we're ignoring other columns. Okay, cool. Now, this is where it gets sketchy. Okay, and you'll see why. Take a look at the max and min score. Okay, so min score equals filtered in score. Okay, dot min, as easy as that is. Max score equals filtered in score dot max. Okay, cool. Now we have, let's take a look at those 2. Okay, you have to write min score, max score, just to take a look at them. So there's a score of 0 and there's a score of 100. In IMDb, I don't know if there's a 100 score in IMDb. At least in Rotten Tomatoes, I don't think we have a 100 score. But yeah, it says based on this that we have 100 scores. Okay. I don't believe we have 100 scores because that means that everyone liked it. That doesn't happen. Never. Okay. Cool. Okay. So get rid. Oh, actually, get movies. Okay. So let's get the better, like the movies with better ratings and movies with the worst ratings. Okay. And again, this is where it gets weird. Worst movies equals filtered. Filtered here, filtered in score. Okay. Double equals min score. Okay, what we're doing is saying, hey, I want to get filtered of score that is the minimum score. Okay, cool. Let's do the same thing. Max or best movies equals filtered in filtered. Same thing, score, but double equals max score. Okay, so in this case, worst movies should have a zero rating, and the best movie should have 100. Okay, good. So welcome to the matrix. Worst movies names score, and I want to get also the budget X. Ready? Yeah. Now you tell me, was Fast X that bad? I liked it. It wasn't that bad. Is a Spider-Man Across the Spider-Verse 0? Nah. I don't know. Daddy Owl sounds sketchy. That sounds weird. Yeah, for example, Step Up, Love Story, Double Love, 0, with a budget of 200 and, wait a minute, 1, 2, 3 of $264 million with a score of 0? That doesn't make sense. Like, if I would be a director with a budget of 264 million to get a score of 0, I would probably do something else for my life. Like, that doesn't make sense. Okay, so that's why it's sketchy. Okay, now it gets worse. Ready? Yeah. I won't read them. Just read. You just skim them. Read them. Okay, so we have Orgasm Lecture 2, which is a score of 100. Better than Fast X? Nah. Really? I tried to look for El Asistente. It's a, I don't know. I found like 3 different movies with the same title. And then you can see something interesting. Every single budget is the same. Okay? That means this data set is not accurate. Okay? Again, I won't read this out loud. Just read it yourself. With 100? Nah, I don't think so. Okay, with the same budget as, I don't know, Pretty Young Sister 4. That sounds just weird. Okay, but let's just ignore this. I just left it because it's fun. Okay, it's funny. Simulant 100, $201 million of budget. Really? Nah, I don't think so. Okay, cool. So that means careful with your data. Okay. Now let's plot it. Okay, we saw it. We see that it doesn't make sense, but you'll get to see that it doesn't make sense because it's clustered in a non-natural way. Okay, let's see how it does. Okay, so filtered dot plot dot scatter. Okay, X equals budget X, while equals score. Okay, so we're plotting the budget against the score. Okay, let's see if our theory is correct, meaning the budget doesn't make the score, or the budget makes the score. Okay, maybe this dataset says it does because we have only 4, 5, 6, 7, 8, 9, 100 scores, and everyone has the same budget. Maybe we should budget the whole movie industry with $201 million. But yeah, let's see. Okay, PLT did X label, meaning we'll label the X as budget USD. Okay, and PLT dot Y label score. Okay, so far so good. PLT dot title. Again, always pretty data. Okay. Movie score versus, let's do money. PLT dot show. Okay. Let's see how that looks. Ooh, 3-2-1. That's horrible. Okay, that's probably one of the worst scatters I've ever seen in my life. Okay, what does this mean? Like how? What? Okay, how did we go from here to this? Let me explain. We have budget in USD in millions. You can see 1 E8. It means 1 to the power of 8. It means 1 times 10. That's power of 1. E1, E2, 3, 4, 5, 6, 7, 8. Okay, so we have thousands and then millions. Okay, so $100 million, $200 billion, all the way up to $400 million. Okay, you can see that there's one that's $400 million-ish dollars. I don't know. If Disney's budget is like 200 million, I don't know who gave this movie 400 million. Okay, give it to me. I can do a better job. Okay, cool. But you can see that with this $400 million, it got a score roughly about 80. We have $50 million standing at 100. We have, so you can ask yourself, say, where are these 10 movies? Where it's the same dot. They're standing in the X and in the Y value in the same place. So you can see it's the same dot. It's this one over here. Okay. It has 100. Okay. With $201 million. Okay. So this doesn't make sense at all. It's a cluster full of lots of movies. This is not accurate. Like, these zeros are the worst movies. Okay. Oh shoot, my bad. Control C, Control V. These 211 movies are lying here. Okay. You can see the worst one. How can we say this? Like, the worst one that costs more is maybe this one over here. It's Fast X. Okay, this is Fast X, which is $340 million. This is the one. Okay, doesn't make sense. Okay, now how can we make sense of this? Like, how can we relate data? How can we do something more interesting? Okay, so there is something called a correlation coefficient. It means I want to see if my X and my Y's are related to each other. Okay, if you want to learn more about correlation, again, some marketing here, watch my linear regression stream on Monday. Okay, I'll see you there. Cool. So let's just use non-formula straightforward correlation. So we can do core equals filtered in budget X. I think it's with small b, but jet X dot core filtered score. Okay, this is the way to do it in a easy way. Okay, non-formula easy way. Okay, yes, I'll see you there, Tammy. Cool. Stats is fun when numbers make sense. When you're in a test and numbers don't make sense, you just hate it. Okay, I've been there. That's what happens. But yeah, some people use R for statistics. I use Python. I don't know. I prefer Python with NumPy and Matplotlib. R is just not bad. It's made for stats for a reason, but I just prefer Python. Okay, cool. So let's do print. Okay, so we do it in a pretty way. Correlation between budget and score is, and then let's do course. Okay. Oof. Oof. Oof, that's horrible. Okay. The values that are close to -1 and 1 means they're related 100%. Okay. So -1 and 1. If you get close to 0, it means your data doesn't make sense. Period. Okay, that's what it basically says. So we got a -0.2. Means these scores and the budget don't seem to have a relation between them. Okay, again, if you want to take a look at the actual formula, like the mathematical formula, I'll see you on Monday, okay, because we're going to do linear regression. But this says it doesn't make sense. So we can, based on this dataset that's fishy, we can say budget doesn't make score. Okay, and let's take a look at it in a different way. Okay, and this is the last thing that we're going to do. Import numpy as np. Okay, just in case. X equals filtered in budget X. Y equals filtered in score. And then let's draw a line. Okay, let's see how a line gives us information. So M and B, if you're not a math person, line equation, there we go. This is your line equation. It's Y equals this one. Y equals mx plus, no, it's not this one. It's mx plus b, right? Here it is. Mx plus b. M being the slope, x your x value, b is your the direction. Okay. Cool. So get rid of this. Probably here. Equals np.polyfit. Okay. X y 1. Okay, the 1 is for the supporting index. Okay, let's just leave it in 1. It's fine. And then we do plt.scatter. X, y, and alpha is going to be 0. Okay, 0.6. Okay, the alpha is the level of color intensity. So 0.6, each dot by its own is going to be a little bit transparent. Okay, cool. Now, plt.plot. Okay, we can do x m times x, which is the line, plus b. Okay, so there you have the line equation. And the color equals red. Has to be a string, red, there we go. plt.x label, budget. plt.y label is score in US dollars. plt.title, let's do score versus money with trend line. What's wrong with my typing? What the heck? plt.show. 3, 2, 1, ready? Horrible. Okay, you can see that each movie by itself is somewhat transparent. Okay, you can see it here, you can see it's somewhat transparent. You can see that this dot is really, really, really dark. Again, because these are the best movies. Okay, these movies over here. Okay, so we have, I think it was 1, 2, 3, 4, 5, 6, 7, 8, 9 movies stacked together into one single dot. Okay, this is fast X, remember? The line doesn't make sense. It tries to see a trend and it says, okay, following lots of different trends or lots of different repetitions, I try to draw a line, but it doesn't make sense. This line is going down. It means a trend of score higher than budget is actually negative. It means no relationship, no can do. Money doesn't mean a better movie. Okay, cool. Nice. I think that's it. Any questions? Anything that you'd like to ask me in the chat? Just in case, I'll share with you the register here. So register here that you completed and watched this stream. Any interesting questions? All good? I think all good. Nice. Okay. Cool. So we have another stream in an hour with Vincent. Okay. He's going to present using AWS Athena and QuickSight to turn. Okay. In 1 hour. Okay. So I'll be there. I'll be in the background just helping Vincent out. It's his first stream. So lots of love for Vincent, and I'll be there just to help. Okay. You won't see me or anything. But yeah, oh, thank you. Oh, no question. So good to see the data insights. Thank you, Tammy. I hope it was fun. Use Pandas, okay? That's a life lesson. If you use CSV with Python, like the CSV library that we used here, okay? Yeah, get help or something. I don't know. It's funky, okay? I don't like it. But yeah, if you like it, kudos to you. Okay, one last thing is, let's see, can I open this here? Yes, GitHub. Okay, so this notebook, you can find it in my GitHub, which is, I'll share it with you. It's Bully 1601. Okay, that's my GitHub profile or username. You can go to my repos, okay? And you can see I have here the Global Hack Week stream repo, okay? Data 2025, which is this one, and you can find the linear regression one that I'm going to do. Intro to Pandas and CSVs. This is the template that I used. And I have another one, Statistics with MATLAB template, which is the one that's going to happen also on Monday, but I think it's like 8 p.m. Eastern. I'm not sure. Something like that. But yeah, then thank you for watching. It was fun. And I'll be seeing you around on Monday at 9 a.m. Eastern with linear regression. I hope I see you there. I'll be at fun. And yep, in an hour, I'll be with Vincent. So yep, I'll see you there then. Yes, I'm at lab 2. A lot of data. Cool. Thank you, Tammy. And thank you all for watching. And I'll see you around. Bye-bye.